This is AQA GCSE Chemistry. It's the bonding topic and it's valid for dual award and triple award students. This is video number 4 in this series, and in this video we're going to start to look at giant ionic structures. I'm going to recommend that you try each activity, pausing the video as you go, and then you get to see your own level of progress and understanding. So, going through, we can see the objectives here. I can describe and explain the melting points of ionic compounds and the electrical conductivity of ionic compounds. And there's a couple of words I am going to highlight here. We're talking in terms of electrostatic forces of attraction between oppositely charged ions, and we are talking about ionic compounds having a giant ionic lattice. So have a think about the melting point. Do we think they'll be high or low? And why do we think that? And in terms of the answer, it has a high melting point. And there's a specific reason or series of reasons why, and you've got to use the right terminology when you're discussing this. So I'm going to break it right down. We're talking about there being lots of something. And whatever there are lots of, they are strong. So lots of strong. And then, I've already mentioned electrostatic forces. It's lots of strong electrostatic forces. Now we want to explain where they are. So those lots of strong electrostatic forces are between oppositely charged ions. And if there are lots of strong electrostatic forces between the oppositely charged ions, lots of energy is needed to overcome them. Now in an exam, you might be expected to draw out an ionic lattice. And on here, it's giving you some guidance. So have a go and see how you do. And it does say here a 3D structure with 8 ions. You don't want to go any more detailed than that because it gets far harder to show what you need to know. Now I always start off by drawing out my square. I've got my plus, my minus, my plus, my minus, opposite charges alongside each other. And I'm then going to turn this into a 3D cube. So I take these back and I continue my pattern. Plus, minus, plus, minus, plus, minus, plus, minus, all the way around, opposite charges alongside each other. We're also going to need to understand whether ionic compounds conduct electricity. And this is a practical that I do when I'm teaching it in a lab, but we can have a think about what would happen. If I take solid sodium chloride and I try to use it to complete a circuit, what do we think will happen? And what will happen is nothing. The bulb will not light. The reason, the ions are not free to move in a solid ionic compound. But what we can then do is think about what happens if I were to add water to that sodium chloride. Now in those circumstances, the sodium chloride will dissolve in the water. Salt dissolves in water. And if the salt dissolves in water, what you find at that point is that the bulb lights. Now for this, we can show that electricity is conducted in ionic compounds when the ionic compound is molten or aqueous. And the reason for that is that the ions are free to move. We know that within the liquid, the ions can move freely through that structure, through that substance. So now let's go on and think about how we might explain why ionic compounds conduct electricity and when. And when is when they are aqueous or molten. And I've just added on here the details. Molten means it's melted, it's been heated till it becomes a liquid, and aqueous means dissolved in water. And that means the ions are free to move and carry charge through the structure. That takes us to the end of this video. Thank you for listening and goodbye.